Y'all, let's cover exponentials. We're still in the percentages and exponential functions lecture pages, student guides, but we are now starting with the exponentials. And I know we're starting with the exponentials because I have an exponential on my page. Anytime you have and don't freak out if you don't know what this is, I'm going to explain it to you. So just breathe, give me a chance, and give yourself a chance because you can learn. All right, I don't expect you to just know this already. That's why you're taking a class. Given the function f of x is equal to 5 times 1.08 to the exponent of x, and it wants us to evaluate the following. So we did this with linear functions. And what we do is if this is f of x and this is f of -1, everywhere there was an x, we placed a -1. This is the exact same thing. Instead of putting it multiplied to, however, it's going to be an exponent. Apparently I want everything in white here. All right, so what I'm going to do is 5 times 1.08 to the power of -1. I do not expect you to do any math to this other than putting in your calculator. Now, you could put the entire thing in, or you could do order of operations, which means 1.08 to the -1 times 5 equals. All right, that's typically what I would do, but to show you that you can put the whole thing in, raised to the -1. So 5 times 1.08, close your parentheses, caret, which is this guy right here. If you don't have this and you're not using a TI, then you might have an x to the y if you're using your phone, or a y to the x. But remember, you can't use your phone for the exam. So you need to understand that caret is your exponent. And then my exponent is -1 equals. So my answer is 4.6296. And we're going to go I'm going to go 2 place values. I know we typically go to the tens place, but I just want to, see why. So 4.63. Okay, there's no sentences here. We're just solving. F to the 0 means 5 times 1.08 to the 0. Anything to the 0 power is 1. X to the 0 power, Sandra to the 0 power, 4.6296 to the 0 power is 1. Let me show you. To the 0 power is 1. Okay. So this is just 5 times 1, which is 5. Now, if you didn't remember that because you're stressed out on your exam, put it in your flipping calculator, y'all. Okay. Same thing. Now we're going to use 3. 5, 1.08. All we're doing is substituting where the x is. We're putting 3. Put that in your calculator. And it's 6.29856. So I'm going to use 6.3 because that's what that's going to round to. All right. Did you notice that? Well, I was going to say, yeah, there's nothing. If there's any questions on how to handle that, please let me know. Okay, those were kind of fun. I want you to do the next one. Unfortunately, this should have said f of x is equal to this. So this should say f of x is equal to 24, 0.72 to the x. So you're going to do the same thing. 24, 0.72, and you're going to put the power of -3. Write down your number. 24.72 power -3 equals 64.3. I want you to pause the video and do the next 2 and then come back to see how you did. Again, anything to the 0 is 1 times 24 is 24. So 24.72 caret 2, 12.4416. Okay, let me know what questions you have on that. All right, now the actual exponential functions and creating them. Okay, so this, if you use what I gave you in the previous video for percent increase, I think it's and decrease, I gave you A is equal to P, 1 plus or minus R. This is the same thing. Instead of A being the ending value, we're using f of x because we're creating functions. And now that we're talking about exponential functions, we're going to want that f of x to be our ending value. All right, P is our starting or initial value, so you're not learning anything new there. R is your rate in decimal form. You're not learning anything new there. So all you're doing now is adding the fact that X has to do with time. And typically it has to do with years, but it could be days, it could be weeks, it could be, seconds. But X is your time. If the number of parentheses is greater than 1, there is growth. So if the number inside of here is greater than 1, there is growth. So this is new words for you. Instead of increasing and decreasing, when you're dealing with exponential functions, we deal with, instead of increasing and decreasing, we deal with growth and decay. So you need to make sure that you have those in your wheelhouse. If the number in that parentheses, and I'm not talking about anything else, only the number in the parentheses, if it is between 0 but less than 1, there is decay. Okay. If there is growth, and I'm going over everything now, and then I'll show you how to do it in just a moment. Here's how you calculate the percent. I'm not going to read this to you because I'm going to show you, and then we'll come back and I'll explain it. And if there's decay, and here's the words of what to do. So for the function, okay, 170, 0.8 to the x, identify the initial value. The initial value is your P. Remember, f of x is equal to P 1 plus or minus R to the x. So our initial value is 170. Identify the function's behavior as growth or decay. Well, the number inside the parenthesis is less than 1, so this is decay because 0.8 is less than 1. I don't need you to do this on the exam, but I want you to understand it for your notes. Than 1. Identify the growth decay factor. It is 0.8. You won't have to do this on your exam, but you will have to do this on your homework. So please make sure that you know that. And then lastly, identify the growth decay rate. So it's the decay rate that we're looking for. So if there's decay, here's how we're going to calculate the percent. Decay is more difficult than, for some people, than growth. And you'll see why when we get to that. Okay, so because we know it's decay, I'm going to take 1 minus R and put that equal to the number in the parentheses. I probably misspelled parentheses. All right, now all we have to do is solve for R. That's the next step. So I'm going to subtract 1 from both sides of the equal sign, and I get negative R is equal to negative 0.2. Okay, I need to divide both sides or multiply through both sides by negative 1 to get rid of that negative on the R. So R becomes 0.2. So I've now solved for R. Multiply by 100. I need to take the decimal for the rate and change it to a percent. I swear this dog was not barking until I started making a video. So this is 20%, and do not forget your percent sign. So the decay rate will be 20%. Okay. You're going to need to practice that one, but not with this one because this one's going to be a growth rate. So I'm going to do both examples for you, and then you're going to get some practice. For the function f of x is equal to 5 times 2 to the x. Well, this 2 is greater than 1, so we have definitely got growth here. All right. The initial value is 5. That's our p. The growth decay factor, it's a growth factor, is 2. Again, not going to be on your exam, but it will be on mom. And then identify the growth rate, right? So to identify the growth rate, we're going to come up here and say, okay, if there is growth, you need to know both of these. You need to make sure you're comfortable with solving these. If there's growth, you're going to put 1 plus r, because that's how it was found, 1 plus r equal to the number in the parentheses. And you're going to solve for r. All right. So I'm going to subtract 1 from both sides of the equal sign, and I get r is equal to 1. Next thing you're going to do, I solve for r, is I'm going to multiply by 100. And that's 100. Don't forget your add percent. So the growth rate is 100%. And there's my sentence. I'm going to keep these formulas close so that we can go over them. All right. For the function h of t is equal to 110, I'm going to write f of x is equal to p 1 plus or minus r to the x. Because that's how we've been learning this. We've got the initial value is 110. This is the 1.3, so it's greater than 1, so this is growth. The growth factor is 1.3. Again, not on your exam, but will be on mom. And then the growth rate. If it's growth, you're going to take 1 plus r equal the number in the parentheses. Subtract 1 from both sides of the equal sign. Multiply by 100 to change it from a decimal to a percent. And don't forget the cute little percent symbol. So the growth rate is 30%. There's my answer. I should have told you to pause the video. Pause the video for this one and work through this one. For the function f of x is equal to 60, 0.7 to the x. Our initial value is 60. This is decay because the number inside the parenthesis is less than 1. So we're looking for a decay factor of 0.7, which is not going to be on your exam, but will be on your homework. And then the decay rate. Again, use what I gave you here. 1 minus r is equal to the number in the parentheses. Subtract 1 from both sides. We're solving for r. Divide or multiply through both sides by -1. It's the same thing. And r is equal to 30. Oh, I haven't done that yet. So sorry. 0.3. Now multiply by 100. And don't forget your percent symbol. So the decay rate is 30%. Okay. Let me know what questions you have regarding that. The next piece of it is we're going to learn to write exponential functions. We're going to learn to write these and these given f of x is p1 plus or minus r to the x. Okay. So our initial value is 110. That is our p. Now, are we growing or are we decaying? Well, they're telling us it's growing. Because they're telling us it's growth, we know we're going to add the rate in decimal form. The rate is currently 3.5%. We don't want to use 3.5. We need to turn that percent into a decimal. So take 3.5 and divide it by 100. Makes it 0.035. Do not forget this cute little x up here because that's what makes this an exponential function. Otherwise, it would be linear, and that would be wrong. The last piece of this is just simplifying what's inside the parentheses, just add them. And that is my exponential function, showing a growth rate of 3.5%. I know it's showing growth because it's greater than 1% in here, so I did a good job there, okay? Next victim. I want you to do this one because it's another growth rate. So pause the video, attempt this one yourself, following the same logic I did, and come back and see how you did. The initial value is 1504, 1,504. I know it's growth, so I'm adding 12%. 12 divided by 100 is 0.12. And don't forget your X up here. So to finish this out, I just need to simplify what's inside my parenthesis. There you go. Let me know what questions you have. All right. Now we're going to write an exponential function. Instead of growth, we're going to have decay. So please hang out with me for this one, and then you can do the next one. All right, so I'm going to use f of x is the initial value, 1 minus r in decimal form to the x. My initial value is 63, and it's decaying at a rate of 28%. So 28 divided by 100 is 0.228. Don't forget your x. Lastly, we just need to simplify what's inside the parenthesis. 1 minus 0.28. It's going to give us a number less than 1 that shows that it is decaying. And that's my answer. There's my exponential function showing a decay rate of 28% with an initial value of 63. Pause the video, do this next one yourself, and then come back and see how you did. We have an initial value of 545. We know it's decaying, so it's subtracting 0.4%. So 0.4 divided by 100. Don't assume that's already in decimal form. It's not. It has a cute little percent symbol, so you need to get rid of it by dividing by 100. Once you divide by 100, that percent symbol poof, goes away. Okay, and this just makes it 0.004 to the x. So 1 minus 0.004 is 0.996. That's all I have to do to simplify this. And put it to the x for your exponent. All right, next one. Pause the video, do this one yourself. This is going to be a growth one, so make sure you're adding and not subtracting, and come back and see how you did. The initial value is 79. It's 1 plus because it's growth. Growth is 119. Divide that by 100 to make it a percent, and it's going to be 1.19 to the x. Clean it up just by simplifying the parenthesis. Oh, that should be a 2. 2.19 to the x. There's my exponential function. Let me know what questions you have regarding that. Okay. Given the 3 statements below, identify which represents exponential functions. So the number of pennies in your piggy bank doubles every year. Well, this one's a difficult one. All right. You need to think about what's actually happening to the money. And if I question not understanding whether it's linear or exponential, because those are your 2 options, I look at it this way. If I start with, I'm going to start with the number 1 because it's simple. If I start with the number 1 and I double that, doubling 1 becomes 2. Doubling 2 becomes 4. Doubling 4 becomes 8. If this was a linear function, it would be going up by the same exact number every time. To go from 1 to 2, it added 1. To go from 2 to 4, it added 3. Well, right there just shows it's not a linear function, so it has to be exponential. So this is an exponential function. And to get from 4 to 8, you're adding 4. So notice it keeps getting bigger by a larger amount. That's totally exponential function, okay? The value of a car depreciates at a rate of 22%. Okay, linear function, again, has to go up by the same amount every time. If it's depreciating by 22% every year, that means that number is going to be changing on a year-to-year basis based on how much the depreciation, what the current rate is. So if it's a percent after this number, it too is exponential. If it's increasing or decreasing by a rate of a percent, it has to be exponential. And then lastly, the temperature is decreasing at a rate of 3 degrees per hour. So that means if it is 100 degrees, the next hour it's 97 degrees, and the next hour it's 94 degrees. Notice in between each of these, it is 3 degrees. This is linear. This is not exponential. This is linear. And you're going to need to know that it's linear because it's decreasing at the exact same rate every time, the exact same number, not percentage, not doubling, not tripling, quadrupling. It's the exact same number every single time. Okay. Now we are going to write some functions. I don't know if they're exponential or not. When a new charter school opened in 2010, there were 970 students. That is my P. No matter what's happening, I'm just going to write beginning. That's my beginning number. Because I don't know if this is going to be a linear function or exponential. There's my beginning number. Using function notation, write a formula representing the number of students attending this charter school T years after 2010. Assuming the student population, and we're going to get different scenarios here of what we're going to write this as. The first one, it's increasing by 73 students per year. That is a rate of change. That is a linear function. So we're going to be writing this as a linear function. F of x is equal to b, and it's either going to be plus or minus mx. It's going to be either be added or subtracted from the initial value. This one's increasing, so we're going to be using plus. So f of x, what are they using here? Are they using a function? They're not telling us. They're using t, so f of t. The initial value was 970. That's our b. And it's increasing by 73 students per year. There's my linear function. Okay. I know it's not exponential because there's no percent, there's no doubling happening. It's the same exact number every stinking time. The next one is assuming the student population decreases by 36 students per year. Well, this one is increasing by an exact amount. This one's decreasing by an exact amount. So this is f of t is equal to, again, the initial amount was 970, but this one it's decreasing by 36 students per year. We're not finding how many students. We're just trying to create functions that we can utilize later. The next one is it decreases by 9.4% per year. These are both linear. This is exponential. So this is going to be f of x is equal to p1 plus or minus r to the x is what we're going to use to write. It looks like these next two. So f of t, the initial amount was 970. That's my p. 1, it's decreasing, so it's actually decaying by 9.4%. So 9.4, to get rid of that percent sign, we have to divide by 100. And that becomes 0.094. Don't forget your t, because it's t, not x, as your exponent. So I just need to subtract that parenthesis. 1 minus 0.094, and I got 0.906 to the t. There is my exponential function. Increases. So this one's got growth because I know it's growth because it's percent. So f of t, 970 is my initial value. I'm going to be adding the percentage, 6.1 divided by 100 is 0.061 to the T. It's kind of funny. I need to add these two, 1.061 to the T. And there is my exponential function. All right, here's the last one. The last one says that the value does not, assuming the student population remains constant. Is this going to be linear? Is this going to be exponential? What do you think this is going to be? Well, f of t, if the initial number of students is 970 and it doesn't change, that means you don't need anything else. We're done. The value stays at 970. And that's linear. The population numbers 1,944 organisms initially. So this is our beginning number, and increases by 5.2%. So this tells me this is growth. So this is growth because it's increasing, and this tells me that this is my P because it's the initial number of the population and each year. Write an exponential function for the population of the organisms. So they're not telling us we can't use X. I'm going to use f of X is equal to P, and I know it's growth, so it's 1 plus R to the X. I need to understand that f of X is my population. I like to let myself know this so I don't have to go back and think, and that X is being represented by years. Because now we're going to be solving for things. And you're going to have ones like this on the exam. So we know it's growth. I'm letting f of X be my population. X is the years. So now I can write my function. F of X, my initial value is 1,944. And then I'm adding, it's increasing, it's growing by 5.2%. So 5.2 divided by 100 is 0.052. And you're going to raise that to X. Now, lastly, I just need to simplify this. Please do not leave this like this. If you can math something and you're not mathing it for your exam, one, makes my hair on my head stand up a little bit. And two, it's going to take a point off because it just pisses me off. Get those two numbers, you crazy kids. All right. Just do it. Just flip and do it. Come on. I know when math accepts it. I ain't your mom. I'm Sandra. So I want you to math it because I know you have a calculator in front of you, silly. All right. Lastly, I know I'm not being mean. I'm slightly joking, but I emphatically want you to add when you can. All right. Now we're going to predict the number of organisms after 7 years. So if you didn't write what these things are representing, you're not going to know where to stick that number 7. Okay. Be careful. So what we're saying is 7 is in years. That's my time. So this is f of 7. And I'm going to take my function that I just wrote and find this answer. Everywhere there is an X, I'm going to put 7. And now I'm going to plug that into my calculator. Yes, I can put the entire thing in, or I could do order of operations where I do 1.052 to the 7th equals, and then times 1944 equals. Or for those of you who are used to doing this in 1944 in school, that think the teachers had you put it all in at one time. Just make sure it looks exactly the same. Be very careful. Okay. So 2772.08. All right. They didn't tell us what to round to. If this were people, you would just leave it as this. Because, I mean, I've seen 0.08 of a person, and you probably have too, but we're just going to say that this is either 0.1, 0.08, or you could say 2772. Mom will tell you what to round to. I may or may not. Depends on if it's people, I won't, because I expect you to understand that this is actually only 2,772 people. But because it's organisms, We don't know what the organisms are. All right. So, but I'm going to answer it as with just this as my answer. The number of organisms are 2,772 after 7 years. Okay. Let me know what questions you have. All right. A population number is 70. Oh, we're dealing with the organisms again. Okay. Initially, and decreases by 8% each year. I want you to pause the video and do this one yourself. Using the same methods I just used, instead of growth, we've got decay because it's a percent. So I know this is decay. I know this is my initial value. Write your function, plug in for your X or T or whatever value, whatever variable you're using, and solve for how many organisms there are after 2 years. And then come back and see how you did. My initial value is 17,000. I'm decaying, so minus 8%. 8 divided by 100 is 0.08 raised to the X. I'm just going to simplify my parentheses. And there's my function. That's my exponential function of decay of 8%, starting with an initial value of 17,000. So when we predict our number of organisms after 2 years, it should be less than 17,000 because we have decay. Okay. So I know that f of X is my population. And this is based on years. So X is my year. All right. So f of 2 years is 17,000 times 0.92 for 2 years. This one I'm going to do by order of operations. 0.92 squared times 17,000. And I get 14,388.8. This is a conversation. The number of organisms are. Now, are we going to leave this as 0.8? Are we going to leave it as 14,389? Are we going to leave it as 14,388? What would you do here? And what's right? If it's people, you can't have 0.8 of a person, no matter how many zombies are around Jamestown. So if this was people, the answer would be 14,388. 388. Okay. There's not 14,389 organisms. If there were, there would be a 9 here. So we don't have that many. And the number's going down. It's not going up because it's decaying. So you could answer as either 14,388 or 14,388.8. I'm going to stick with the fact that organisms are like people and say there are only 14,388 in 2 years. Okay. Next one. In 2014, Rose invested $16,000 in a savings account for her newborn son. The account, whoa. Yeah, okay. The account pays 3.6% interest each year. Determine the total value of the account in the year 2032 when her son will go to college. All right, and then round your answer to the nearest cent. This will be the last one I do for this video, and we'll do something different. So Rose invests 16,000. That's the initial amount. The account pays 3.6% interest. There's her rate. And the total value of the account in the year 2032. So we need to figure out the time. First, let's write a function. Initial value 16,000. It's increasing. It's paying 3.6% interest. So 1 plus 3.6 divided by 100 is 0.036 raised to the x power. I'm just going to simplify this real quick. Okay, now I can solve this. Determine the total value of the account in the year 2032 when her son will go to college. So take 2032, subtract the year she invested it, 2014. 18 years. So over the 18 years, I know that f of x is the amount of money that they're going to have. X is the number of years. So f of 18 the last one I did order of operations. This one I'm going to just put the whole thing in. So 16,000 parentheses 1.036 raised to the 18 equals the value of the account, using their words, will be, because it's 2032, we're not there yet. I can choose the verbs now. Will be, don't forget your dollar signs. We're dealing with money here. 30240. 30240.96044. Okay, we're America. So we're dealing with money. We have to go to the hundredths place. So we go to the six, the next number over zero. So this stays six. So 0.96. So she invested 16,000 in 18 years. She has just over 30,000 for her son to go to school. Okay. Let me know what questions you have. I'm going to make the next one in the next video. Let me know what questions I can help you with.